Hello, everyone. My name is Yongkang He. I'm very happy to be here today to talk about how to migrate the containers from one cloud to the other cloud in just about 3 minutes. So today's topic is about how to migrate from Azure AKS to Amazon EKS. Literally for small workloads, you only need about 3 minutes. So previously, I actually recorded multiple videos to talk about how to migrate containers from on-prem to the cloud, from OpenShift to another OpenShift, from a different cloud. Also, recently I also recorded how to migrate from a Rancher RKE to VMware Tanzu. So today we're going to focusing on how to migrate Azure AKS to Amazon EKS. So let's set up the demo lab first. So I love the automation. So I'm going to use my automation to create an AKS cluster plus MySQL plus also Kasten K10 pre-installed, including the backup policy, everything done ready in just about 8 minutes. And secondly, I will create a target cluster, which is based on Amazon EKS, comes with Cassandra database, and also have Kasten K10 pre-installed policy pre-configured. And last but not least, it's very important in order to migration from both of the cluster, you need to be able to access the common storage bucket S3. Okay, let me jump to the console. I got one tab open from Azure AKS. So I am actually logged into the Cloud shell, and I'm in the folder AKS-K10. So all I need to do is just run deploy. So after I kick off the deploy command in about 8 minutes, the whole environment will be ready. And while we are doing the AKS build, I will also show you from AWS Cloud. I am also logged into AWS Cloud shell. But to make it simple for AWS, actually, for EKS cluster, it does take about 15 minutes to create. So I'm not going to wait so long. So what I'm going to do is I already pre-create empty EKS cluster. So I will show you shortly if you don't have an EKS cluster. So what I'm running here is I got one node EKS cluster. It is running 1.22.9. and it is running from a US East 2 region. But if I'm going to list the namespace, you might notice I don't have anything installed yet. So how to deploy Kasten K10 to a running cluster? So if you already have an EKS cluster running, I tell you what, you only need about 3 minutes to enable the backups. So all we need to do is just run a command, K10-deploy. So in about 3 minutes, we will deploy Kasten K10, deploy sample database, the backup policy, everything will be created. So I kick off the command here. Now let me show you where you can find the script, where you can find the automation scripts. So the first tab here, so this is a AKS-K10. This is a repository. And from the repository, you might notice there are multiple automation scripts here. If I click README here, it will jump to the instructions page. So how to create the whole environment. If you don't have an Azure account yet, we also recorded a YouTube video to walk you through how to create an Azure trial account. You only need about 5 minutes. So once you have the environment ready, you already have an account. You open up an Azure Cloud shell. You clone the repository, and you do create an Azure app registration first. Once you've done this, I actually already did the clone. I already did the preparation tasks. All I need to do right now, I'm actually just to kick off the command /deploy from Azure Cloud. So in about 8 minutes, all of these tasks will be ready. So the first one, create an AKS cluster from a command line. Second one, install Kasten K10. And by the way, this is a #1 Kubernetes native backup tool. And we also deploy MySQL database and create an Azure blob storage location profile, create a backup policy, run the on-demand backup jobs. All of these are done in about 8 minutes. And once you've done your testing, I also automated to destroy, to delete the whole lab environment. Okay, that's about the AKS. If I'm interested to know what about the EKS. So if I'm going back to the top, my GitHub page here, I actually created the automation for all top 5 public cloud. So Google Cloud is here, Azure Cloud here, Amazon EKS. So this is EKS-K10. That's my EKS cluster automation. I'm going to click README, go direct to the instruction page. So how to do it? You go to Cloud Shell, you clone the repository, you run the preparation tasks, and then you can deploy based on your needs. So earlier, what I did is I run the K10-deploy. So basically, I just do install Kasten K10, deploy Cassandra database, create an S3 location profile, create a backup policy, kick off on-demand backup jobs. But what I did earlier is I actually pre-create an empty cluster, which is I run the command EKS-deploy, so just to create an empty cluster. If you want to automate both of the steps, that's the last column. You just run /deploy. We create everything. Once you've done all of your testing, you can destroy based on your needs. Okay, moving down to the screen, you can see there are multiple YouTube videos to talk about how to create an EKS cluster, how to protect the containers in 3 minutes, how to build the environment via automation. And you might be interested to the Kasten on AWS workshop. It will walk you through step by step how to do the granular individual resource recovery, how to do the full restore in place, how to clone to a new namespace, etc. Okay, let me come back to the Cloud Shell. Let's see what's happening. So remember, we just deployed Kasten K10. I already have an EKS cluster up running. So the scripts has completed. You might notice the total time, it took 1 minute, 7 seconds. By end of the scripts, you got the URL here, copy the URL. I'm going to open a new tab here, paste the URL to the web browser, press enter. So you will be asked to provide the token code. So I'm going back to the Cloud Shell, copy the token, and then paste the token code here, press sign in. So now it will ask you, this is the first time I log in, it will ask you, what is your email address? What is your company name? Click accept. So you will log into the Kasten Web Console. Did you guys notice? When I log into the Kasten Web Console, it's very simple, very easy to use. I'm actually already have the backup jobs finished successfully. So did you guys notice here? Now let me confirm what about Azure Cloud. So come back to the Azure Cloud Shell. It is still building, but hopefully it should be up running shortly. So let me come back to my slide deck, just walk you through a little bit. So remember, when I build the lab environment, I use 2 automation scripts. One build AKS plus MySQL. The other one build EKS plus Cassandra. So this is a high-level diagram of how it works. On the left-hand side, I got an AKS cluster. I have MySQL running. I got managed disks. This is running from Azure Cloud. I also have all different Kubernetes configuration objects to support MySQL applications. Kasten K10 was running in a separate namespace. Typically, we call Kasten-IO. The moment Kasten K10 deployed to the cluster, we will automatically discover all of these resources. How to do the backup? We talk to the API server. We discover all of these Kubernetes resources. We take a snapshot of your application, of your configuration, and your data. So remember, maybe somebody deleted the whole cluster, or maybe the whole data center is gone. There is some risks. Your snapshot also sitting in the same cluster. How you can recover? You can't recover if you're in a serious disaster situation. So we always recommend customer to send another copy to the external object storage, which can be far away from your primary data center, can be from a different region, which is more safe, more reliable. Not to mention you can enable the object lock to avoid the ransomware attack. So now on the right-hand side, I got the Amazon EKS cluster running here. So you might have noticed I don't have a MySQL application, but I also have a Kasten K10 installed. We just did the installation a few minutes ago. So now how I can quickly migrate my MySQL application to the target cluster. All you need to do is you just configure another policy, do the import. Once the import finish, we will do the restore. Once the restore finish, you might have noticed my MySQL application will be up running from my target cluster. So I will show you the live demo shortly. So on the high level, just 2 steps. Step 1, from my source cluster, I need to configure backup policy. Part of the backup policy, I will export another copy to the S3 bucket. So that's why I create, first of all, I need to create a location profile to point it to the S3 bucket. You need to use a common S3 bucket, which can be accessed from both AKS and the EKS. And we will do the backup from a source cluster, and we will do the export to Amazon S3, but it can be any other cloud S3 or on-premise S3 compatible storage, or even NFS storage also supported. Now from my target cluster, all I need to do is just configure another policy. This time it's not a backup policy, it's the import policy. And a part of the import policy, we will also do the restore. So obviously we will use the same storage bucket name here, and we will do the import. We will import MySQL from my source cluster, read from the S3 bucket, and then we will restore MySQL to the target cluster, in this case, EKS cluster. Typically in about 3 minutes, the MySQL database will be up running on my target cluster EKS. And optionally, you can also migrate back. You can migrate MySQL from AWS Cloud to Azure Cloud in also about 3 minutes. So by now, my lab environment should be up running. Let me come back to the Cloud Shell to confirm. Yes, it is. So 7.5 minutes, Azure Cloud, including building the AKS cluster. All good. So here is a link, copy the link. Actually, the clicker doesn't work for Azure Cloud Shell. So what I need to do is I need to copy the link. I need to paste the link. Oh. I copy the link. I paste the link to the browser, press enter. So same thing, first time login, you will be asked to provide a token code. I'm going to copy and paste the token code to my Kasten K10 web console. Click sign in. And from here, again, you will be asked to provide your email address, your company name, click accept. So I log into my AKS cluster as well. Now I got my lab environment ready. I got my source cluster on the left-hand side. I make it, light. I make it a light, background. And on my right-hand side, this is my target cluster. And I'm going to go to the settings. I want to make it a different background. From the dashboard, I can make it a darker background. Okay, just to show you the differences from my right-hand side. That's the Amazon EKS cluster, my Kasten K10 running on Amazon. So from the URL, you can also recognize it's, by the elastic load balancer, AmazonAWS.com, okay? So now how to do the migrate from my source cluster. All I need to do is, what I need to do here is, I need to configure S3 bucket. I'm actually already have an S3 bucket, but since I'm going to migrate from AKS to EKS, I might just create a location profile from Amazon S3. So all we need to do is, you need to provide the profile name, you provide your AWS access key, your secret key, choose a region, and also you need to provide the bucket name. So how to enable backup immutability? You just take the option, but obviously you need to have the your S3 bucket need to support the object locking feature. Okay, that will avoid the ransomware attack. So for now, I'm not going to expose you my access key and the secret key. So what I'm going to do is I will use my automation to create the S3 location profile. But if you want to create from the UI, that's the way. You just fill out the form and click Save Profile. So I'm going to come back to my Azure Cloud Shell. All I need to do is I create a migration. I got the automation scripts, migration -S3 location. So press enter. So shortly the command finish, and come back to my dashboard, do a refresh. You will see my AWS 3 migration profile has been created. This is my bucket name. So remember, in my target cluster, I also need to have the same bucket name. But since I already have the location profile created, now let me create a backup policy. So you can, from the UI, you click, this is my application. And from here, I can create a policy. Say, I need to create a new policy, give a policy name, choose the action type. You can configure the backup frequency. You can make it hourly. You can even make it, every 10 minutes, 5 minutes. It is also doable. And you can customize your snapshot retention settings. We always recommend enable backup via snapshot export. This is where you can choose your object store location profile. In this case, I want to migrate to AWS, so I will choose the S3 migration storage bucket. So once you've done all of these settings, you might notice how to select your application. So you can select by the namespace. By the namespace, in this case, Yongkang-MySQL. Or you can do the label-based selection. Let's say the instance match the label MySQL. Okay, once you've done all of these settings, you just click create a policy. Before you create the policy, if you want to generate the YAML file, let's say MySQL backup. So you click the button YAML, we will generate the YAML file for you. Okay, for now, I'm an automation guy. Yeah, I don't really want to click here, click there to create the policy. So what I'm going to do is I will use the automation to create the backup policy. All I need to do is I just run the command AKS2EKS MySQL policy. Press enter. So we will create a backup policy first. And once the backup policy finished, we will kick off the on-demand backup jobs. So right now, if I'm coming back to the custom dashboard from our Azure Cloud, do a refresh. So you will see I got a new policy created, AKS2EKS MySQL backup. And it is copy, export to the K10 migration for Yongkang dash, it's a long bucket name. You need to have a globally unique name. So it was created from a US East 2 region. Okay, so the policy has been created. If I'm coming back to the dashboard, you will notice my backup jobs also kicked off. So now we just need to wait the backup job finish before we can do the migration, do the import from the target cluster. Okay, so if I coming back to the slide deck, you will notice from step 2, so first of all, we need to wait the first job finish, backup finish, export finish, and then from my target cluster, I can do the import. Before I can create the import policy, I also need to create a location profile. Again, I'm an automation guy. I will use my automation from our AWS Cloud Shell. I also have the automation scripts here, migration S3, and press enter. But let me confirm first. So first of all, from my target cluster running on AWS Cloud, from settings, you might have noticed that I do have my AWS S3, but it's not the same storage bucket which I was used for my source cluster. So what I'm going to do is you can, from the UI, create another location profile pointing to the same storage bucket. What I'm going to do here, we're going to use the automation again to create a location profile from my target cluster. So we will first of all create the S3 profile secrets. I'm actually already have the secrets. So we just create the location profile, finished, do a refresh. My AWS 3 migration profile also created. This time the bucket name matched the name from my source cluster bucket name. Okay, so my target cluster is ready. Come back to the dashboard. So we just wait the source cluster backup job finish. So the job is still running. If you click the job details here, so you will notice my backup job actually already completed successfully. Remember, we capture your application components, we capture your Kubernetes configurations, we also capture your data. So if I click the job details here, you can see we discovered all of your Kubernetes resource objects. So for example, you can see your persistent volume claims, your different spec artifacts, your secrets, your configure maps, your role binding services, etc. While we're talking here, you might notice the job almost finished. So with this great visibility, we actually give you the flexibility. In case somebody accidentally deleted secrets or configure maps or whatever, any one of the Kubernetes resource objects, we allow it to choose the individual resource to do the recovery. For the purpose of this demo, we're not going to focus on the granular recovery. We're going to, shortly, I'm going to show you how to migrate the application, MySQL application from AKS cluster to my AWS EKS cluster. So if I click the applications tab here from my source cluster, I do have a Yong-MySQL database. So right now my job just finished. I got 2 restore points. And from my target cluster, let me just confirm again. So I got 2 applications as well, but I don't have the Yong PostgreSQL database. What I have is a default namespace and the Cassandra. That's part of my automation. I deployed the Cassandra database to EKS cluster. So now let's create the import policy. So since my job just finished, back to the dashboard, click the policies. All I need to do is create a new policy. Let's call this policy import MySQL. And this time it's not the action type, it's not a snapshot, it's import. So how I can read the data from my source bucket. I needed the token code from my source cluster. Where to get the token code? Come back to my source cluster, go back to the policy, my source backup policy, AKS2EKS MySQL backup. There is a show import details here. I click the link, click the button, copy to the clipboard. I got the token code. Coming back to my target cluster, I paste my token code here. So now we discovered the application, profile, the location profile, my AWS migration. So by doing this, we only allow you to read the data from the source bucket. But I need my application, MySQL, also up running from my target cluster. So there is an option here. After you read the data, you can tick the box here, restore after import. So part of the restore, we will transform your applications. We will apply the powerful transformation to allow you to recover from my target cluster. I'm actually forgot one thing I want to highlight here. Coming back to my source cluster from the command line, if I do get my node status, you will notice my source cluster, it's a 2-node cluster. It is running 1.21. My target cluster, let me confirm another stuff. In my source cluster, I was using Azure Managed Disks. That's why you see all these different storage, class. But from my target cluster, I don't have any class name match this. So we need to apply the powerful transformation engine. So part of my restoration, I can apply the powerful transformation engine. Let me confirm one more time. I got 1-node cluster running from my target cluster. It is running 1.22. Remember, with this way, the application mobility, we allow it to move from one cloud to the other cloud, from one Kubernetes distribution to another Kubernetes distribution. We also allow it to do from the lower version to the newer version, or from the newer version coming downgraded to the older version. Okay, so just to confirm, from my target cluster, all I have is the GP2 storage class. So part of the transformation, let me come back to my Kasten web console here. I need to apply the transformation. So otherwise, you will find when you're trying to restore, you will say, I can't find the storage class because you don't apply the powerful transformation. So I'm going to add a new transformation here. I will change my storage class from the original one to my target storage class name, which is GP2. I need to edit the operation, create the transformation. That's all I need to do. So not only we can, first part, we read the data with the token code, we will read the data from a source cluster. And with the powerful transformation engine, we allow you to transform to use the target storage class, which is GP2 right now. And another thing, all of these storage class from my source cluster, Azure File, Azure Managed Disk, CSI, all of these actually, if you recover to my target cluster, it is useless. So I tell you what, we allow you to filter the resource. That's another cool feature. Part of the restore, you can exclude some of the selected resources. For example, the storage, the CSI, all of these storage class, there is no point to restore to my target cluster. So I'm going to add this filter and that's it. I got my policy ready. All I need to do is to create a policy. But if you want to automate it, again, you can click the YAML button here. Did I forget anything? Actually, I do. I forgot to choose the how often I'm going to do the import. So we can use this to do a one-time migration, which is you can choose the on-demand. But you might want to make it every half hour or every 10 minutes. You want to have a standby DR somewhere else. So we are allowed to choose hourly, and you can customize, you can make it every 5 minutes, every 20 minutes, or every 30 minutes. For now, let me make it every 30 minutes. So that means you always have a backup from your source cluster every 30 minutes. From my target cluster, I will do the import, do the restore every 30 minutes. So you will have a standby DR, okay? So now I got everything ready. So I can click a YAML file. This is a YAML file. If you want to automate, you just copy. This is a copy button. You can copy to clipboard and then you can save it to a file from the command line, from your automation tool. You just run the kube control, apply or create -f with the YAML file, or we'll create the policy for you. Okay. So for now, let me just go ahead and create the policy. And now let me keep a watch from my AWS Cloud. If I'm going to watch all the pod status, you will see the detailed progress. By the way, Kasten K10, we're running in a separate namespace, Kasten-IO. All of these pods are our Kasten minimum maintained pods. So we just launched 24 minutes ago. And now let me come back to the Kasten dashboard. I'm going to run the job immediately. So instead, when you wait for the next scheduled job, I can go ahead, just click run once, click confirm run policy, and I can go back to the dashboard to monitor the import restore process. So remember, we still only have 2 applications right now. After the import, after the restore, you will see 3 applications from my target cluster. Okay, come back to the Cloud Shell. You will notice the Kasten-IO, we already launched some temporary ports, data mover. That's the container. We allow you to read the data from all the source storage bucket. And once the job are finished, shortly, we will spin up some temporary port to process the restore jobs. Okay, I might just keep the job running. It might take just 2 minutes. It's most of the time less than 3 minutes. So I might just walk you through a little bit from my slide deck here. So this is a high-level step, just to summarize, do the backup policy from a source cluster, do the import policy from my target cluster. That's it. So simple, so easy. 3 minutes is not a dream to migrate containers from one cloud to the other cloud. So these are major use cases. Why customers use Kasten K10 for the application mobility? So they want to reach the container portability. They want to easily to migrate from one cluster to the other. They want to use running some applications from on-premises, some applications from multi-cloud. So we make it easy. You can easily flexibly move from any one of your applications to any other Kubernetes cluster. So we allow you to easily to migrate between different clusters efficiently. And we also allow you to simplify the upgrade maintenance. So remember I mentioned earlier, we allow you not only you can upgrade from a lower version to the higher version, we also allow you to do the import restore from the newer version, downgrade to the lower version. So 3 major use cases to simplify the upgrade, to apply the powerful transformation engine to allow you to easily migrate, efficiently migrate from one cluster to the other. You can leverage it as a clone for your testing dev cluster. You can easily clone the application from your production environment to your test dev environment. So while we are talking here, so the job should be up running shortly. So you might notice some of the job. So initially the data move job, read the data. Once the job is done, it terminating the ports, and we use the affinity port, that's the temporary port, and then we restore the data. That's the restore, container port. And then you will notice actually MySQL database, it's already up running. Not only running, you see the 1/1, not only up running, also pass the readiness check. So now if I'm coming back to the dashboard, so did you guys notice? The application now becomes 3, and my job is completed successfully. So if I click the job details, you can see the first subtask, we do the import, it takes 9 seconds. The second task, doing the restore, it takes 53 seconds. Totally just less than 2 minutes, we complete the restore migration from AKS to EKS. So just to confirm, if I click the applications here, you can see I got my SQL application is up running from my target cluster already. But I don't have a policy to back up my target Yongkang-MySQL yet. So you can just go ahead to create a policy from the UI, and it's all these settings. But you guys probably love the automation. You want to fully automate it to be part of your CI/CD pipeline. How to automate it? I also have the automation here created here. So all you need to do is just run the MySQL policy. So we will create the backup policy from the target cluster. So press enter. Not only actually we will create the backup policy for you, we will also kick off the on-demand backup jobs immediately. So I think that's pretty much all I want to cover for now. Let me come back to the dashboard just to confirm I got the new policy created. Do a refresh, you can see this is from my AWS EKS Amazon Cloud. I got a policy Yongkang-MySQL backup also created. And go back to the dashboard, you will see my backup job is also kicked off. So everything looking so good and so simple, so easy to migrate one, any particular application from one Kubernetes cluster to another Kubernetes cluster. And let me come back to my slide deck here. So we already talked about the typical major use case, why customers love the application mobility, just to including a few reference links. So my automation code, all available from a GitHub page. So the command which I was running earlier, you can find from the AKS link, from the EKS link. If you want to watch the YouTube video, I also have a separate video to talk about the AKS automation, how it works. Also talk about the EKS automation, how it works. And the third link is about Kasten. We provided the Kubernetes free training. After the training, you will collect all of these popular Kubernetes badges. I love it. And the last link is about Kasten Documentation. That's our official documentation page. If you guys are interested to learn more about the automation tool, you want to learn different Kubernetes cluster from all different public cloud, I build the automation to cover the top 5 public cloud. Here are the links. And additional information about how to build the Kubernetes cluster, how to back up the containers, how to migrate containers from one to the other, how to build and protect the containers via the automation. Last but not least, feel free to follow me, to join me to learn multi-cloud and the Kubernetes together. So by now, I'm already 43 times multi-cloud certified, including CKA, CKAD, and also CKS. Feel free to subscribe to my YouTube channel. It's going to be popular. So in less than 1 year, I already have 1,000 subscribers. Thanks everybody, join me, supporting me. That's all I want to talk about for today. Yeah, thanks for your time. Feel free, again, feel free to connect with me via LinkedIn, follow me via any one of the ways, subscribe to the channel, and also feel free to follow me from a GitHub page and also Slack channel. Thank you very much. I hope it is useful to you. Feel free to, provide any feedbacks or any comments. Thank you very much.